Hey guys, how's it going? So I'm remaking this video because I found a better way to cache function responses, and I'm going to be sharing that with you today. So in the last video, we created a function called getLatestRelease, which we called in our Google Keep Desktop API, and now we're gonna make that cached. So let's get started. What do we want to cache exactly? Well, we want to cache the value that we're going to be responding, and so we need to add an expiry time to it so that we know when to actually, and we need an expiry time so that we know when to refetch that value. So create a new struct called tarry GitHub release, or whatever that function of the first parameter is. So if we look at the function we want to, cache, we see that it is called getLatestRelease. And what does it do? It basically creates a tarry response for a GitHub release. So we want to call it something similar to what the function does. What does the function encompass? Okay. And this is what the function responds with. So we just say value because it's a JSON value for us at least. For you guys, it could be anything. Then we want to also say an expiry time, which is a system time. So just import system time. And now we got to get into some basics of Rust concurrency. So the thing about state is that it has to be atomic, and we're not using atomic responses. So if we look at the Rocket documentation, we can see that for state, they are using an atomic usize. So if we go to the page for atomics, we can see that there's nothing here for a long string. Okay, you can't cache a string is not atomic, basically. That's what I'm getting at. There is an atomic pointer over here, a raw pointer type that can be shared safely, but I'm not entirely sure if it's even a good idea to be using raw pointers and experimenting with that just to get atomic values over the other available things. So what else is available to us? Well, we can either put it around this struct around, we can wrap it around with either an RW lock or a mutex. But what are the differences between these two? Well, let's go over here really quickly. So how Rocket works is that it's all asynchronous, so we don't have to worry about two different threads. Okay, that's what we don't have to worry about. So what about the differences? Well, mutex is pretty simple. Every time we need to access the value, either to read or modify it, we have to get a lock. Oh, sorry. Okay. And our RW lock, or a read-write lock, as you can see here, a reader-writer lock, sorry. A reader-writer lock, how it works is that only writes are require exclusivity. So if multiple if you want to lock multiple times for reading, okay, this will not block. Okay, so acquired lock for reading, it won't block. Write lock will block. Okay, so this will block and stuff like that. And what are the implications of this, or consequences? Well, the consequence is that the RW lock is much better and it's much more sophisticated, which also results in better performance. So to implement the RW lock, it's a bit more sophisticated, but we get better performance for what we want, because we want to be able to have respond with the same result multiple times. The old video that I had on this was using an LRU cache, which required exclusive access for simply reading the map. And that's going to hurt a lot at scale. So yeah, this is better. Now, one thing to note here for better performance is it kind of sucks if every 15 minutes, one of your users will end up having to wait an extra second or two for a response. Now, maybe that's not bad, and it really isn't that bad. I mean, my store implements it too, but maybe you are really craving that additional performance. So I also have a note on memory safety across threads. And another way you could cache it more efficiently, since this video only talks about caching, it doesn't really talk about how to cache in the most, how to use that cache in the most effective manner. So what you could do is you could have a background thread that you start on Rocket's Ignite with your custom fairing. And what that does is it modifies your state every 15 or 5 minutes. And yeah, every 5 minutes it updates that state so that your code in the front end, or sorry, in the back end over here, you don't even have to worry about writing. You can just acquire the read lock and respond with it. You don't have to worry about writing on a request. And since it's in the background, the request that's being made to GitHub and everything, the processing is not going to be taking up user time. And the only thing that'll be taking up user time is when you write a new value, which it'll take like less than and take like a millisecond or something, right? So that's going to be insane, but it's also difficult to implement. But I have a note on atomic reference counter there if you want memory safety across threads. And yeah, maybe in a future video I will experiment with how to do that. But anyways, we have created our things over here, and we've wrapped our tower release, so our struct, we've wrapped it around with an RW lock. And like before, or maybe I haven't said it, since Rocket has a limit on the number of values per state, obviously, that's kind of intuitive why they'd have that. We want to create a type just for our Google Keep desktop release, or for whatever different parameters you are using for your function, and you wrap it around RW lock and Tower GitHub release. Next, what you want to do is create a helper function for creating a RW lock and your function response. So what I have here is RW lock new and Tower GitHub release value as nothing and an expiry, which is now. Okay. So moving onwards, let's add this to our Rocket instance. So we want to import new Tower GitHub release as well as Google Keep desktop release. And down here, we want to create a new variable called Google Keep desktop release, which is our cache struct or cache type, and just call that initializer for the struct. And you'll see that works. And then what we want to do is we just want to click .manage as before. Okay. And then we go over here. And one thing I want to show you is how to run your code more efficiently. So what I have here is two tasks, one to install CargoWatch and one to use CargoWatch. So what you want to do if you're starting a new Rust project is create a file called vscode/task, and don't hide this in gitignore. You can copy it from my tutorial. You just copy this and you can see that you can install CargoWatch as well as use CargoWatch. And what this does is it lets you edit and not hot reload your code, but auto compile code upon changes. So I'll show you an example here. CargoWatch -x run. So this will run cargo run, but it'll watch for changes. Now come down here to get latest release and create the same function, but put a TTL afterwards. And we want to say, okay, latest release takes in a state of the type RW lock Tower GitHub release. So this means that we can take in any amount of public types that are basically aliases of the original type. And what we want to do is we want to say, okay, let's take that guard, let's lock the latest release for reading. And if the guard has not expired yet, we want to return that value. Otherwise, we want to drop that guard and we want to acquire a latest release.write guard. Now, what could go wrong here is if you did two things. when you acquired this guard, it's possible that this code in another request has run and that has taken a read first, and now there's going to be two different requests acquiring the right guard. So what you want to do immediately after is do the same check. Okay, you want to do the same exact check so that any cleanup, if there's any duplicate locks on the right, then it won't, mess up and call GitHub twice. So this will prevent any redundant requests to GitHub. And now we just call let release equal get latest release, client.repo.await or else, error, print error, okay, unwrap. That's pretty easy. And then we say guard.value equals release.clone, that's obvious. And then guard.expiry, just set the expiry to whatever that TTL is. And you can do that with checked add, and then duration from the unwrap, and then we can just return that release that we got. Okay? And then we just want to call this function from our original endpoint, and we want to add another state, which is called cache. And yeah, it's going to be of the type Google Keep Desktop Release, which is nothing but an alias for RW lock, which works perfectly fine with get latest release over here. And just to show you that it works, let me refresh this page and you can see it all works fine. So I hope I did not skip over something over here. Maybe I skipped over some imports, so I'll go over that. So import RW lock, and you want to also import system time. And also you want to import JSON value. And the last thing, if you're coming here from the old videos, if you've watched the old videos, you want to remove those helper functions I have in utils, and you want to remove the LRU cache from the dependencies, because we don't need that anymore. But anyways, oh, and don't forget to set this variable at the top for TTL, which is nothing but time to live. Anyways, I hope I didn't rush through this video. Maybe this part is confusing, so I'll just leave it here for you to read it. But yeah, I did find this bug here just now, which is that it would have been possible for there to be two different requests that want to acquire the right guard. And yeah, this is just takes care of it so that nothing else happens. Because it's possible there's no guarantee that this is the next code that'll get run. It could be that this code of another request gets run. We just don't have any idea what the sequence order is, right? And like if it's a lock, maybe it runs in a first in, first out basis, and whatever gets read first is the one that does it. I was learning concurrency in class, and that bug just stood out to me just now. But yeah, concurrency is complicated, but I hope I made it simple for you guys and improved a way, or gave you guys another way to improve your caching abilities, and in a way that catches bugs as well. So make sure you can drop the guard over here so that nothing goes wrong. And you have to manually drop it, and then you want to acquire it with the mutex for mutating, and you want to make sure you run that same check again so that nothing goes wrong. And yeah, and that's how you edit it. So yeah, I hope you guys found this video useful. I'm not sure what my next videos will be. Like I said, I'm experimenting. I don't know if I told you guys specifically, but in the Towery video I made, I'm working on C# right now as a backend programming language instead of Rust, because I don't think Rocket has some capabilities I wanted to support. I wanted to do it properly in one code base, and C# could do that. Rust doesn't really work on mobile, so yeah. But yeah, I'm learning ASP.NET, and I've created some blog posts on that as well. So if you're interested in C# or ASP.NET, you can just look at my blog and see some things I've said on there to help you make a better program than what Microsoft gives you off through their tutorials. And yeah, see ya.